great. I will update the event time after the meeting. So for people here, now next week we will be back to Monday this time. Okay, let's get started. Start with the update.
Yeah, not too much to say here. We got some new prototypes, the new GPU docks in. Back in the office, do a lot of testing on those, get those ready for launch. We'll try to have 1,000 in stock on launch day. We think that this might be Proma's highest sales day in history.
Do we have a launch date?
Yeah, tentatively May 21st, but not gonna be it's not gonna be hit.
May calendar May 21st. Oh, great! I will be there.
Cool. Yeah, but we'll definitely have them. I just want to test them and do the USB 4 stuff. Make sure our firmware works with USB 4.
Great. Do all the load tests, stress test.
Yeah.
Sounds good. Anything else?
Oh,
Okay. Let's move on. We start with Llama.
We had our first under 3-hour run.
great.
Where is our under 3-hour run?
Let me post that. That runs under 3 hours.
This is wait, what?
It says 2 hours, 57 minutes.
Oh, okay.
Are we sure it's
Does this? So this doesn't include logging, right?
This doesn't include yeah, no ML logging.
Okay, but to your best knowledge, this with logging should be good for submission.
Yes.
I trust you on all the like frequency of eval and things like that.
wait, why does it not have logging? What?
It doesn't have ML perf logging.
Why not?
We only do that when you do running time.
Oh, and we should be doing that. We should always be doing that. Does it add time? Like,
No.
Yeah.
Yeah, I think just make sure logging is there and all the required fields are logged and the eval frequency or whatnot that's to the rules. And that would be good. What's the main difference?
It's a lot of stuff. It's just a lot more custom kernels.
Oh. Why are we still 50% slower than 30% slower?
Our gem is slower. Our flash engine is slower.
Is that really why? We post the latest.
It's a bit slower, and then function makes a copy.
Yeah, I mean, this is a lot of that. Fix that.
Function makes a copy. It saves.
What's the one liner to benchmark? Should take 2 minutes, right?
Do you know how many rounds do we need for this?
5.
Okay, so we can do this in a day. Nice.
Okay. Oops.
And this MFU is compared to what? I see 18 something %, but is this like a super fast 8 something?
The MFU is not entirely accurate. It's a pretty bad metric because we don't have everything as FP8. Like the output head is not FP8. The flash attention is not FP8.
But that 18% is of the FP8.
Yes. 4.6.
I mean, that's a decent metric still, right? Like it's theoretically what you can get if you saturated the.
Yeah.
Okay, so yeah, realistically, our time's probably going to be like 2 hours 45.
Yeah, it's about 2-3 weeks. So I think it's important to make sure the loggings are correct. These things we can fix as early as possible.
I'm doing that. I mean, this sprint is basically submission sprint, I think.
What's
I
the
think
what's the deadline?
Submission is May.
I think 17th. Let's post it.
Good.
Somewhere.
About the sprint.
Cool.
Yeah, it's May 11th.
Yeah.
About like 2 weeks.
Oh, it's May 11th. It's not 6. It's not 17th.
Wait, is it 11th? Oh, I'm confused. Okay, I'll double check. It's that week. Okay, anything else for Llama?
That's about it.
Okay. Let's move on. The next is the new device. It was new.
Yep.
Still.
Yeah, I mean, the syntax hasn't really changed all that much. I think it's pretty stable now. But yeah, so now you can put AMX in there, and I don't actually have a Windows and ARM laptop that tests, but it should work now. And also apparently we didn't support BSD AMD64 because they put lowercase AMD64, so that should be fixed now too. But yeah, if there's any other machines that people run into and they're like, oh, this doesn't work, then open an issue or send a message. There's also a new when you run Python M tinygrad.device, it'll print more. It'll print the interfaces. So, like if an interface doesn't come up, then should tell you why, and then it shows you which ones are available, and also like how many devices you have available on each one.
Still complaining about that runtime warning.
Yeah.
What you do? Basically, you need to make all the imports in grad init easy.
Mm,
Wait, you should only have to make the tinygrad.device or like make all of them in yeah, that's annoying. Oh, because they probably import tinygrad.device. Okay, yeah, that makes sense. It's something. It's not a real error because this like module project doesn't actually like.
I'm not that worried.
It is annoying that the print down.
Yeah.
More annoying is that NV calls sudo. You find this really annoying.
What? If it's not passwordless sudo, it hangs or something?
I don't know why it calls sudo, but there are if you like grep for sudo within the code base, there are a couple instances of sudo whatever.
Good. Those are good things to clean up.
Yeah.
It calls reserve huge pages before it initializes NV.
Oh, does it? Yeah, because I think I've seen this on comp devices before, where it complains that this file doesn't exist.
Yeah.
Yeah, it sounds like that sort of stuff can be cleaned up. I don't know. Oh yeah, you can have multiple USB devices plugged into your laptop now, and that works. I tested it with Omnist multi GPU, and worked. USB 3 works on Mac now. Also, previously it would work the first time you ran something, but then it wouldn't work the second time. But now it works as many times as I've run it. So
cool. Is this the set interface stuff?
Yeah. It looks like I don't know if it's actually a bug in IOKit, but it's something about IOKit behaving differently than what Linux does when you. Do a set
Yeah,
interface.
it's like probably correct. You should probably clear the endpoints and set interface anyway. The stock firmware does.
Which almost issue?
Same, you can only use it once issue.
Oh yeah, they experienced the same bug, and the symptoms were very similar, but the solution was very different. But I think that's mostly it. Like, there's other.
So the Tinycorp device show mock.
No, I intentionally excluded that. I could include it, but I thought it was just kind of confusing because like most people probably don't want to run on Mach.
Oh, I think we should definitely include mock.
Okay, all right.
Yeah, I mean, it's kind of interesting because like then you get like AMD, right? Like AMD NV fails right now.
Yeah,
Yeah, I think we should include it. I don't think there's a reason to exclude it. It's not like null. I don't think we should include null, but
Okay. Yeah.
mock is correct. You can always just use it.
The other thing I considered putting in there was like you could put like the architecture of the devices that are available. So if you're like, oh, well, what do I have plugged in over USB? You could say, oh, you have GFX 1200 plugged in over USB.
Yeah, it'd be cool also to print the total RAM.
Oh yeah.
Yeah, how much RAM each device has. If we have like generic tools
Yeah.
to query that, will it show me the number of devices I have? What if I have like
it's
multiple?
it's right there, right below KFD.
Cool. I'm so used to just SSHing it to $10, but that's not fast anymore.
Yeah, but if there's anything else that would be useful to put in there, we also maybe JSON is useful if I don't know if we see the LLMs find this useful to look at. Like the way that I feel like I use the LLMs, I usually tell them what device I want to run on, so that really don't really need to query the devices that are available. But maybe it's useful.
Like booting the GPUs? Why is it so slow?
I don't know. It's not this slow on my computer. I should try.
Is Clint
It wasn't that slow on my computer, but
Thank
Yeah.
Campaign.
what happened?
AM.
AM hang?
That's
No, it's like in like who knows what kind of state. What tail scale on the Mac, so we can hit the BMC if we have to. Oh. Well, the AMD driver was inserted. I broke the kernel. All right. So much for that computer, right?
Okay.
Uh,
Anything?
Yeah, if there's anything else that would be useful to be printed there, or that you think like maybe an LLM would like to have access to, or whatever, you can definitely put it there. And yeah, whatever seems.
Looks good. I think anything that can read, anything that can run kernel and run it correctly, we want to show it here.
Yeah,
That's it.
yeah. I mean, do you want to show mock and mock KFD? It's essentially the same thing.
You can decide. It's like basically all these combinations that is materially different, but we can use it to run actual kernels. We should list it here.
Yeah, makes sense.
Okay. Next, I just put backlist.
Yeah, so my first approach was too ambitious. My first approach was like a rewrite of the devectorizer and the expander. It's doable, but I don't think that's probably the right way to do it. My second thing, which is working, is mostly working, is I just replaced I just fix all the logic. Everywhere it used to look for V count, it just looks for shape. And yeah, this mostly works. I have to still solve the problem of how to specify. So I have it working, it's correct, but it's not doing load fusion. So I have to figure out like how we want to specify, right? Because right now the way that we specify a load for is through the D-type vec.
Mhm.
That's the only one that is like this. It's just loads. So yeah, I have to figure out what I want the new syntax for that to be. Yeah, it was slow going last week.
You can just load what's the new one? Stack?
Well, so stack is just a replacement for devectorize, right? Stack is just a movement on. Sorry, stack is a replacement for vectorize. So stack is just like stack the tensors,
Oh, you just need
create a leading axis and stack the
yeah,
tensors.
yeah.
But no, this doesn't answer. This still doesn't solve the problem with load, right? Like the problem with load is how many elements do I want to load? Like, that's not really specified anywhere.
You can load a shape.
Yeah, you can load a shape, right? That's yeah. I decide on what I want to do for that.
Yeah, makes sense.
Well, I mean, loading a shape gets really interesting because then, like, you want to load a 2D shape. Where's the stride?
No, just contiguous shape.
Yeah, I mean, there's some things that kind of like
Do we have instructions that load weird stuff?
yeah, right. Like,
Some of those DSP stuff can load weird patterns.
not that weird. The DSP is pretty straightforward, but the thing that DSP can do interesting patterns on is the L2 cache prefetch instruction. That can do 2D patterns.
Okay.
Yeah, I mean, I think eventually we want to move load to copy anyway. I don't know. I had a lot of wrap up stuff in Hong Kong to deal with last week. I didn't get a lot of time on it. But
Okay.
yeah.
I'm really looking forward to vector being done because
All right.
some of the mixing stuff is blocked by that.
Okay. Yeah.
Cool.
Top priority. That and USB 4 will be this sprint.
Sounds good. Anything else? Okay. Next is our mixing stuff. So made good progress. I think now tensor is like 800 lines, 800, 900 lines. Put down another 200.
Right.
Anything that's left is either intentional. So few things I think that's blocking, like cleaning this further. One is multi. I don't know if we want to rethink multi or even do something about it. Multi now is slightly annoying.
Yeah, I mean,
And
multi's clearly wrong. I don't have the
okay.
the vec stuff. I know the solution for the multi stuff. I don't know the solution for yet.
Yeah, multi is annoying, and some of the methods has different behavior for training, and those I also don't see how to move. So, for example, like attention or dropout or anything that touches that. Then there's anything that's input dependent, like non-zero or mask select, that goes the item now. X has a weirder way to deal with it. I don't really know now. Then there are functions like cache or kakak that I can probably move. Also, kakak is blocked by shape changing bigcast, and I also don't know what we want to do about that. Because previously it was only supported on tensor. And
Why is cast still here?
because the UUP one has the D-type vec. So I can kind of move it there, but
Okay, so this is blocked on GDEPFAC. Okay, well, we're just
Yeah.
gonna delete GDEPFAC. So that's just, and then the shape changing bitcast. I mean, the shape changing bitcast already is not. It's not doing anything. It's fine. Why can't you just copy that?
oh, we want that? I was not sure.
Yeah, I mean, I think it's fine. It's not anything special. Yeah, I think that can go in. That can go in UOps.
Okay. Then other thing is we have a disk special path. So
Yeah.
I spent another day try to move that again. It's doable. It's just also annoying and bunch of special paths. Just one special path to another.
Yeah.
So that's that. Then all a random thing. I can move it to a random mixing, like kind of Jack style, if you put the seed and size as an input.
Yeah, I think that's. I think that,
Basically turn that into a functional thing.
well, yeah, I don't think we want to change the Tensor API, but I think that Tensor should call into like a functional version of it.
Yeah, okay. So if we want to, if we want to do, I'll probably need to study how Jax does that. But I think the idea is to make it functional and make the seed like an input.
Yeah, yeah.
Then there should I would move like bunch of the inits like codes into
Weirdly,
RAM.
counts an input too.
Say that again?
Does counts is also an input.
Yeah, the seed and the size, right?
Yeah.
Yep. Then there are even more annoying stuff. Let's get item. I moved some of the normalization logic into helpers, but because tensor suppose both indexing with UOP and tensor, we can probably make an analogy for like UOP and you index with UOP, but then you run into your issues for, do you mean like symbolic get item or something like that?
Yeah, I mean, we should be able to use the index UOP in more places.
Yeah, then our current index is also not that or not just that.
Yeah, I think
For
with
now,
this is
for now, the UOP get item means something different.
yeah, no, I know.
So
Um,
so there's that.
I mean, that's a big unification project, but I think the UOP one is fundamentally more correct. Like you see kind of where this is going, right? Like we can write anything you can write in Tensor in UOPs, and it's just so much easier to reason about this stuff in UOP land because
Yeah,
it's
so
all
if you see my test underscore tensor underscore UOP underscore mixing, that test is basically compare applying a function on tensor and get its UOP to applying the same function to the UOP, and the output should be the same.
yeah.
Or subject to variance of those unique. Yeah. Another annoying thing is div, because it literally means different things. In UOP and lower it means C div, and the upper means the Python div. This I don't really know. And that's pretty much it. That's all the tensors.
Yeah, it's nice and small now.
Also, so how do we want a completely different metadata? Because I can restore the current behavior fairly easily.
You can't. I'd be shocked if you could.
What do you mean? You have the metadata on all the UL.
Yep, that's great, right until you do a single graph rewrite. And then the problem is, so there used to be a hack in graph rewrite map that would preserve the metadata when you did a rewrite. The problem is now when you do a rewrite, and not even just a rewrite of that UOP, when you do a rewrite of any UOP, anything that's downstream of that UOP is now recreated as a new UOP, right?
Yes, and I just take the union of that input and say that's a new metadata for the new UL.
But how do you know? how do you know, unless you have something like graph rewrite map, how do you possibly know?
Metadata attached to UOP, right?
The metadata is attached to UOP, yes, but how do you know which original UOP this corresponds to?
Which one?
So think about like a long graph, right? Let's say at the top of the graph, you're putting in a const 2, you rewrite that to a const 3, right? Every single child UOP in that graph is going to be rewritten.
Okay.
How do you preserve the metadata?
Oh, it's just a global dict, right? UOP is all cached and shared.
Yes, but so when you do the rewrite, right? How do
Uh-huh.
you know? How do you know to preserve the metadata? How do you build the map from the input to the output? You right? Because all your output UOPs are completely new UOPs.
Okay.
We used to solve this using graph rewrite map, but graph rewrite map was terrible and is now deleted.
I'll check again. I just do it in the rewrite, and that seems fine.
You can try that. You'll hit a whole bunch of edge cases. Maybe we don't care that much. Maybe it's just a best effort thing, and you can just do it in the rewrite. I mean,
So one thing I know is best effort is if we decide to put metadata attached to UOP through either global map or whatnot, because it's cached. So anytime if we have two operations that generate the same final UOP,
yeah.
you need to pick one. But that was always there. And that was also why one of the tests was flaky, because the global thing conflicts.
Yeah, I mean, I don't really think it's the right like solution anyway. I think that the right
Oh, yeah,
solution.
so that was my question, because that seems to be fairly easy to bring back, but I don't know if we want to bring it back.
Well, I think that before we answer that question, we may want to bring something like it back. But I think the next question to ask after the metadata project is, so we have this function now called apply UOP in Tensor.
Uh-huh.
Right? Tensor should basically no longer inherit from mixins.
Mm,
Right now, Tensor is a subclass of op mixin.
Uh-huh.
Or subclass of op mixin, but we should remove that and we should create like a forwarder. And then this forwarder creates functions.
Yeah, I feel something like that. That's how we ultimately want to do that.
Yeah. That like just think about how beautiful the graph will be, right? Because function should already completely work with backwards pass. That's no problem.
How does it work with assign?
Well, you already can't differentiate a sign.
Yeah, assign is also an issue even in the current method. But anyway, I see the grand idea.
Yeah. There's no assign. It's not like the function thing is just it's a pure substitution, right? That's why I split it into function and call. Function is stateless. Like I actually want to enforce that. I actually want to enforce that function can't have store inside of it. Right, so anything that uses op function has to be pure.
Is that true now?
Maybe.
Okay, but the goal is to make that true. So.
Yes, the goal is to make function pure and then to make all these things pure. And then if you want to do something like an assign on a tensor, yeah, I mean, that's not going to be in a function. That has to be in the big graph.
Okay. Anyway, from my end, I will probably this week focus more on the random. Then we should have like very little left after that.
Yeah, the removal of that, the removal of tensor subclassing op mixin and then just having a forwarder is kind of like the final, like like I said in my message, these rabbit holes are deep, but there's nothing beyond. Okay, another big project after the VEC project is going to be the removal of D-type from UOP. So UOP is just gonna have op, source, and arg.
Great.
tag.
And then you can move a lot of the current broadcast D-type logic.
Yeah. Oh yeah, broadcast D types and broadcast shape should move to the UOP D type resolver. The broadcasting of shape should move to the shape resolver. And we can have passes which add them explicitly if it's needed, but we can imagine a pass that just adds the reshape and the expand or the cast. But yeah.
Another interesting thing at maybe around that time will be the actual weak int and the. So currently it's slightly annoying because for the index one, we really want to something that represents infinite with integer. But if you think about it, anything that act2 should upcast to the same infinite with integer. But we also want like a weak that's below everything and turns into that if we have turns into any concrete int. Basically, in this hierarchy, we want like a one is very low and one is very high. And currently, we are mixing the two in this weak int.
I don't follow this.
Anyway, it's so now we have some rules saying in the index or the weak int or the anything we use for indexing that touches actual int, what's the D type of that? We have a rules, but that rules is in the rewrite, not in the D type promote logic.
Oh, I see. Yeah. No, I don't like that. I also don't like. I think I want to move. So right now we have like define var, which has a min and a max. I think we just get rid of that min and the max, and then if you want min and max, you can just like write them explicitly as uops, which are kind of good anyway. Just
I
like
don't have an opinion on that.
Yeah, I mean this deals with a lot of the like indexing can go out of range stuff. Just don't let indexing go out of range. Instead of like making define var, instead of making it a promise, just make it explicit. It's not like it's slow.
Okay. Anyway, that's more further down, and we can move on. Another big thing is JIT and exec item refactor.
Yeah, so I removed exec item, so now both JIT and schedule use run linear. So I mostly removed all of the runners as well. So I'm just on the path to remove compiled runner. Yeah.
Instead of compiled runner, you have a UPAT match. What file is that in?
I mean, it's all in realized.py. So,
Yeah, so you have this PM exec thing, which is going to replace everything.
yeah.
Cool.
I mean, it's currently call it, but I've already refactored. I removed the program spec. It's now program info. It's mostly renamed, but also sees as the argument to the program.
I'm really liking the direction this refactor is going. I think PM exec is very clearly understandable. I think it's way more understandable than what existed before. Yeah, PM beam. I mean, these things are finally kind of in the right place. I know that comma has a regression with the no locals thing.
Yeah, I'll merge this today. Already have PR, so actually no locals will be also like rewrite rule for now in the compile linear. Yeah.
Yeah, no, but yeah, great work on this. I'm very happy with this. Feels like one of those projects that it's one of those really one of the last legacy systems. And then everything's kind of UOP.
Yeah.
Yeah, I mean, I think kind of the next thing is going to be starting to move more and more of the drivers into UOps. I think we need something like a wait.
Can you repeat? What do you wait?
Yeah, so like think about
wait. Yeah.
wait.
Okay.
Yeah, right. Like think about moving the so currently you're like compiling to PM4 in the HCQ graph stuff.
Yeah.
Like that should
Yeah.
kind of move to UOps too.
Yeah. So also, so actually Graph is also like currently implemented like in the old way. They just use linear instead of JIT cache. But so ideally they should just reuse the same, the same runtime functions.
Yeah.
Okay, it just was really annoying because like it's really hard to add like the decoder into the HCQ graph now because there is a lot of logic. You just need to copy and paste into the HCQ graph. So yeah, I'll make
Wait, what do you mean
these
add
to be
the
shared.
decoder?
We have the decoder, HEVC decoder for NV, and
Oh,
it's not an HCQ graph right now. Basically, it's possible to do that, but you basically need to copy all this logic into basically all this code in the HCQ graph. So
yeah. I mean,
let's say
I'm
to make
talking
it
about
look,
AMD compute queue.
yes.
I'm talking about like AMD
Yeah.
compute queue becoming a UOP graph. Right? And then we effectively have a renderer. It's a renderer, right? Like we have a renderer which takes the UOP graph and converts it into the literal bytes that get pushed to the queue for the GPU.
Yeah.
It's a project. And this is not expected to be done in like a week or anything. But yeah, I think like AMD compute queue and AMD copy queue become renderers for for graphs, right? Like copy queue is a renderer that targets the SDMA engine. Compute queue is a renderer that targets the Mac.
Okay. Yeah. Actually, then I thought about that. I would think that we just have some like a context per HCQ device, and basically all these lowering will be just rewrite rules. You basically have these ops copy, and instead of like going to execute them, you just in a device specific way convert them to bytes, and only that after that you just execute that with some custom function or something like that. Yeah.
I mean, this gets fun to think about. Like where I first realized that this was obviously the path was on the web GPU stuff, right? Because on web GPU, like the thing that you want to output is not sure. Okay, I have these bunch of functions, right? They're web GPU kernels. But the thing that I eventually want to output for web GPU is a JavaScript file, right? So then you have a renderer which can render a web GPU run graph into a JavaScript file, and that's effectively the same thing as the like compute queue renderer. But instead of rendering it to
Yeah.
JavaScript, you render it to the Mac. Yeah, that's kind of the final form of that. But I do think, and I'm probably deluding myself, but I do think these things are getting really close to the final form. And have I said this for many years? Have I always said that we're close to the final form and we never are?
It's probably inch half every year or something. I don't know.
Trolling what?
You probably get it closer and closer.
Yeah. But
And yes, that was there probably 2 years ago.
well, I just don't want to like fall for some like halting problem crap here, where it's like one of these things where you're always like, oh, it's gonna halt, and it never will. But like, I think it does.
I think we have traversed a lot of bad designs. So if we believe the ultimate elegant solution is there, we are certainly closer.
Yeah, I mean, we've definitely traversed a lot of bad designs. It's just a question of like, is the bad design space so massive that we haven't even like touched exploring all of it yet, or we're actually kind of really getting to the end? Because if it's the former, then this doesn't work. But I don't think it is. I think these things are like the UOP graph is this final form of ultimate elegance that there's nothing better than it. Right? And then this still doesn't answer the search question. The search question is probably going to define a huge next era of the company, right? The question then to ask is like, okay, how do we find the best possible graph? Well, good luck, but like at least we've defined the language. And I think we are getting close to defining a complete language that's kind of optimal.
Yeah, that makes sense. I mean, search acts on your state of your language, right? So once you have a compact language, then you worry about the search, but not the
Yeah.
other way around.
Yeah, and I think that this is a lot of conversations with GPT 5.5 about like if this works or not, and like who AI search is really going to benefit. Like who's going to benefit from AI? It's interesting seeing all the things on Twitter now where people are saying like, remember that time we all used AI to code and everyone now just codes by hand again? I posted this thing I liked in Thomas Slack about how like the LLMs have created this simulacrum of knowledge work. And only if your target is truly perfect, right? If there's any amount where your target the answer can just look good but be wrong, then the LLMs will find that. But if we can really define a tight, compact language, and then the other thing that GPT was really saying what the make or break would be is if the LLM generated or the LLM searched for graphs are human understandable or not. And it's super important that they are. If at the end of what we've done, like one of the problems with vibe coding is you end up with this huge repo that nobody can understand. It's useless. Totally useless. It's useless to LLMs too, because if humans can't understand it, LLMs can't understand it. But if the LLM could pour tons of compute into finding small graphs that implement things fast, well, that works. But that's a question of really making sure the language is all correct. So I think LLM search benefits us way more than anybody else, but we'll see.
Okay. Anything else from Imogen?
Oh, no, I think this week I'll remove compiled runner. I just still need to look into the tiny F machines issues. And yeah, probably we'll add this feature for llm.py. It's not .py, but for LLM, so just to set the compiled, to say the graph.
Oh, by the way, are we doing the llama training on two machine thing, or we're not doing that? Does it work? Okay.
Oh yeah, I don't think
He's not going to get back to us.
by May 11th we're not going to have two machines.
I see. Okay.
We can't even train on TA4, can we? Yeah, okay.
Yeah, that's fine.
TA3 doesn't break.
Okay. Next is this.
Yeah, so we reproduced Kimmy's result on M3. And the CLI got a little bit cleaner. In general, just better defaults from watching how the LLMs use it. think this sprint I wanna like move to the bigger models.
Is that stuff merged that fixes the overlap of the WMS?
I merged the stuff that discovers the exec pipes. So it turns out I couldn't find a way for the RAME and the VALUs to ever like execute at the same time to overlap, even on RJNA4.
Okay, yeah, it looks pretty good now. I don't think there's any overlap.
Oh god, there's overlaps. There's overlaps. I have a
Oh,
I have
RDNA4.
pickles.
How about RDNA3?
RJNA4. No, RJNA3 never overlaps.
Okay. Yeah, I mean RDNA4 still has that bug that we have to find. But no, I mean
I tried very hard for the RJNA4. So
find it and you can't.
I am 90% sure it's a hardware bug because AMD's decoder reports the same.
Yeah, that sounds
Timestamps.
like a bug in AMD's decoder that we're also relying on. I would be shocked if it was a
I'll
hardware bug.
try more. The deltas look correct. Like I have 10 packets. I have it down to like a pickle that has 10 packets, and Claude couldn't find it after like 2 hours. Like what the bug is.
Yeah, well, Claude's an idiot.
I mean, like I look at it too, but like the numbers look.
Yeah, I mean it's possible it's a hardware bug. I don't know. Do you have like a
It was
clean
only like
repo?
one cycle.
If it's a hardware bug, let's write it up and complain to AMD.
Yep, I'll do that. It's also non-deterministic, which is really annoying. Like, but if you get lucky, you can reproduce it very easily by just like
Yeah.
issuing VAMAs in a loop,
Yeah,
no
I mean,
RAM access.
yeah, if you can write a small repro that uses AMD's decoder that reproduces it, then yeah, I think we can like submit a bug report.
Right. Yeah, I'll do that.
Yeah, the other thing, I think you guys are both having this problem with putting the contiguouses in on function, the extra contiguouses.
Yes.
Function makes an my issue is that function makes an explicit copy for tuple outputs.
For outputs.
Yeah, for outputs of the function to save, it makes params and then does a store into the param, and then this does an extra. This creates copy kernel.
Interesting. Can you look into that? Is up?
So the issue is that the store is contiguous.
Yeah, or something is making it contiguous.
I think I have the opposite problems. The inputs are contiguous, and that's very odd.
The inputs being contiguous, I understand why I wrote that. And that's yeah, but by the way, what I want you to work on this week is using any of this stuff. We need to make anything we can do to make MLPerf faster. I want you to get LLMs using this stuff, whether it's LLMs or human, or we just gotta make this faster. 245 is good, 230 is better, 215 is great. We can hit 215, that's like competitive with their thing.
What's did you use the profiler so far?
Yes, request that it prints per step instead of sum.
It should. Yeah.
Nimuljan, do we also have any tricks we can do to juice it a little?
I can take a look into this.
Yeah, let's
I don't know if it's possible. We're hitting PVT limit already. Like all of our map models hit that. Like that's why it's so much faster. We push into power limit.
We push into power limit. Okay.
Yeah.
Yeah. Anything we can do? Anything that we can do to juice this? Let's go. If we can beat 127, that's incredible. That's the worst time on the board right now. But yeah, any copies we can avoid or any. Yeah, no, I want this this Viz profiler stack working on Llama and working to make Llama better and working to auto discover bugs. Let's figure out why it's slow, what we're doing that we don't have to do. All that.
Cycle time is 2 minutes, I think. Should be.
Cool. Yeah, let's I mean it's 2 minutes, but you can also do Llama layers and make it faster. Right?
Yeah.
Yeah, I mean we
2
don't have
minutes
to
for the full.
2 minutes for the full thing. Yeah, we don't have to do the full thing. Just do Llama layers. Get a fast one, get a representative one in 30 seconds. And then we can throw the best LLMs we can at it. Okay, yeah, it's kind of the deliverable for this.
Sounds good. Anything else?
I guess that's it. The custom kernel issue with contiguous inputs, I think, is pretty obvious. Like they have to sort of like reason about walking the graph back to the point that they wanted to do fusion. Because it can be like in multiple files, it can be in different layers. And it's
Fix
like
fix for that is not obvious
there's
to me. But I mean, we should just be seeing if we have any kernels at the end that are just stupid copy kernels and why we still have stupid copy kernels. We obviously can't fuse inside the custom function.
Hmm.
Right? Like we can't, the custom function is a barrier. The only thing that we can maybe fix here is there any place where that contiguous is actually just creating a dumb copy of something that's already contiguous? Like if that kernel's actually doing something, then there's nothing we can do. Yeah, I mean, how
yeah, a
many?
lot
How
of these
many?
are also solvable by a lot of these
I
are
mean,
solvable by like storing them transposed.
yeah, but even that requires changes to the custom kernel, right? How many in Llama? How many dumb copies do we still have? How many copies that actually do nothing are we still doing? Why?
I think most of them are because of the gem, because the gem requires transpose.
The transpose is not a dumb copy.
I mean, sort of like a pure transpose. Like, okay, dumb copy. I'll get that.
Yeah,
I'll
how
get
many
that
actual completely dumb? A transpose is not a copy, right? Like how many actual dumb?
Yes.
I'm just literally copying these bytes for no reason. Do we have? Yeah. We have a gem that doesn't require a transpose. How much would that help?
Hip kittens requires because of how the FB8 whammies are structured.
Yeah. Okay. Maybe this isn't one of the low-hanging fruits then.
Yeah, they also don't have primitives for transposed FP8 gem. I looked into this a little bit.
How many custom kernels do we now have?
Back again. Like a fused Atom dilute kernel.
All right.
Yeah.
More than 6, I think.
Now,
More
there's
than 6
more
unique.
that I haven't merged yet, just because it's really ugly right now.
Mm.
To clean it up before I merge it.
Okay, let's move on. We have 5 minutes left. Alma seems to be not very happy about any red. What happened?
The JIT refactor. Yeah. This was discussed.
Yeah, it's This is no local thing. It's the thing they're frustrated about now. But
Can you make sure that it gets updated for them?
yes,
Is there a way that we put slightly more stuff in our test?
yeah. So the
This-
thing we need to do is put their new compile. So they don't. They have a new compile script that they use for some stuff, and then they still use compile 3 in some places. I was kind of hopeful that they were going to stop using compile 3 altogether and use their new compile infrastructure entirely. I don't know if this is going to happen, so I need to bug and see if we need to support both of these or what. But we definitely should be testing this. This bug in particular, this no locals issue, is like pretty weird because it only happens when you load the pickle instead of process. But yeah, I mean, we definitely should be just testing the way that they expect to use it. Yeah.
Okay. I think if it's easy, then we can put that in our test. If it's really convoluted, then we can discuss.
I think right now the new compile script depends on stuff in OpenPilot, so that makes it a little harder. But Armand said he was going to remove the dependency on OpenPilot, and then we should be able to just use that.
Yeah, I mean, there's a limit for what we reasonably can maintain, right?
Yeah.
Their actual device runtime tests we already cannot run. That's why previously when I was trying to make a speed fix, someone needs to run it for me, and that doesn't really help.
All right, which we can't run?
So because they care about the 3 model running concurrently on the device with no other things running, and the actual end-to-end time of that is what they really care. So even if I say, okay, in benchmark I improved this, it's not actually true, and that makes it really annoying.
Yeah,
Like that to happen.
I don't know. For some reason, I was under the impression that they were going to be rendering stuff on the CPU now, and it wasn't going to be an issue. But apparently, that's not true. So I don't really know what's going on with that.
Yeah, I think the bottom line is the actual features we support, we should try very hard to not regress those. So things like
For sure.
no local, yes, I understand it's a hacky flag, but regressing those behaviorally is really bad.
Yeah.
Then speed issue, I think that's something we can discuss with Kama directly more as like what's reasonable to maintain.
Yeah, for sure. Yeah, the other thing that they're annoyed about, which I'm going to fix, is the runtime dependency on the internet for AMD. This isn't really an issue for anyone else because most people don't delete their cache directories every reboot. But we have a solution for this, so it shouldn't be an issue.
Okay.
I mean, going to lib firmware is better anyway because like if people have lib firmware,
Yeah,
we should check the hash. But
yeah. If you mentioned this, but if they update, like if you have an older version of lib firmware or Linux firmware, then you might be loading the wrong firmware, or maybe there was some update that got released that we want to have.
yeah, we should push the hash on the thing. We should
Yeah.
check the hash for the version we download too.
Yeah.
Fast.
Okay. I think let's see short term, let's try to get it in a good state so that they can upgrade a version or whatnot. I think this happens every time we make a big refactor and a lot will complain. And if we believe we are getting closer and this is the last piece, then I won't worry too much about it. Just making sure
Yay! Last refactor.
we'll see.
I think this was
Wow.
especially bad because they were simultaneously doing a big refactor of how they use Tinycorp.
No, this is great because then they can not fully blame on us. Last time they did nothing for 2 months and it regressed super bad. So
Yeah.
okay, I think let's just try to be supportive and at the end, like learn something since this would be also potential issues for future users, and see how we can remove bad tests and add like actually useful tests to our benchmark for them. I think that would be nice. Cool. Serge, can you see what's the state for whatever models we want to add support to and things like that?
Yeah, so B1TG says it's got Kimi running.
Great.
So yeah, that's exciting. I mean, Kimi 2.6 is great. And actually, I realized this coming back here, talking to the common people, what I've been doing for the last few months, which is like learning all about how to run LLMs, and learning all the new tricks. So yeah, it's been cool. So yeah, Kimi is working. I don't know how he did the sharding. The sharding is kind of annoying because you have to shard. You want to shard at like the GGuff level. You don't want to shard. Maybe for Kimi it's a little bit different, but you don't want to shard after because you want to make sure it stays in like 4-bit or whatever. So, yeah, I mean, supporting Kimi would be great. Are there like PRs for other people who want to support other things? Or I think we got most of them.
The other big one would just be Deep Secret 4.
Yeah.
Well, what wants to support that? I heard that's a kitchen sink.
Yeah. Don't waste time on DeepSeek before. It's even questionable. I think we should probably support
I do
GQA.
expect Kimi 3 to be very similar.
We will see
They
when we
seem
get
to
there.
come from the same attention residual design as MHC.
Yeah, MHC itself doesn't seem that bad. The
Loss attention is
yeah. I mean, it's just they have so much weird stuff in there that I think of the like 4 weird things they have, one of them is going to stay around.
I think
and we
this
shouldn't.
is very similar to our early logics for what to include in the end. I think if a trick is used by 2 or 3 labs, then we incorporate those.
I think that's right. Yeah.
Okay.
Yeah. I mean, yeah. And I don't know. I don't know why exactly we don't support Gemma 4. I mean, that's the other one. I don't know if we're missing anything in particular for it, or it's just.
Okay. Anyway, deep glad to you.
Cool.
Okay. Thank you everyone. So next week meeting will be moved back to Monday. And so see you next week. Bye bye.
Bye.